Hello everyone. Welcome to Data Science Foundations, an introduction to your data science and AI journey. My name is Sumudhu Tenekon. I'll be conducting this educational series to educate general public about the topics in data science, machine learning, and other related fields. I'll be mainly sharing my knowledge I gathered over past few years working in the field, as well as I'm going to discuss about the current trends and development. Today we are going to discuss a very interesting topic, which is generative AI came to the general public in last few months with a lot of development in the field. I know you will be conscious about what is happening around you in social media and news and your workplace. People are talking about this new developments such as ChatGPT and other related technology, and other tools available, right? So you previously used certain AI tools for various tasks, but now you are more into this field and you are talking about it. You are hearing things in social media and news. You may have questions, you may have some doubts, or maybe you are a very optimistic person. You are looking forward to use this technology to get something done with it. With everything you hear in the news, social media, and everywhere, and probably you already experience with the technology or tool, ChatGPT, Google Bard, or any other AI tool you recently interacted with DAL-E for the image generation, etc. So let's try to understand a little bit more about the technology and see whether it can help you to do your job better, or to be like better employee to your company, or maybe to help your education using these tools other than hindering your development as a human being, right? So let's try to get the best out of it. So that's what our motivation should be, and that is what I'm trying to deliver this content in the future videos, this video and some few videos in the future. Before we going to discuss anything about artificial intelligence or generative AI or any specific thing of the technology, we first better understand how human evolved into the stage we are at right now. So we came long way. Our human civilization, we don't know exact timeline or how far we should go or how far we will go in future, we don't know. But in the timeline we know few things. We invented fire, we invented wheel, and then we invented how to read, how to write and communicate with each other, and later we invented the printing press, which allows us to do the mass production of knowledge. And then we invented how to communicate with each other remotely, like the telecommunication technology was a major breakthrough. The telephone, radio waves, how we can send the radio signal to a different location, and also it made like radios and television and remote communication possible. And then we invented computing technology, and it evolved in across like several centuries, from the mechanical computers, analog computers, and to digital computers. So maybe in the future we will be using quantum computers, maybe in very near future. And then it came like 1990s, a major breakthrough, like which was the internet technology. So how people can connect to each other, how the computing devices, how different organizations, how different group of people and communicate, connect, and share knowledge, share data, share their views in a more efficient way, the more better than how people did with the telephones, like using the telephones, television, and the radio signals. But now the internet is here from 1990s onward, so we experienced a lot of development. Social media, online platforms we can use for to do our work, to buy our grocery shopping list, and to do take our education, right? So people experience a lot during the pandemic time. So it changed how we work. Our remote work was very possible with the internet and other related technologies. We could do our work without going out from home. We could buy things, or the online grocery shopping, and we could learn, the students could learn using the video conferencing and other technology or the software tools built upon the technology we have right now. Okay, so what is the missing piece? So AI is the missing piece to this picture, and also that will be our future. I have to say something about AI. People think AI is something new. It is invented within the last 10 years or so. Some people think it is invented within last 2 years, because that's how they know, okay, about this generative AI, ChatGPT, and some other technology breakthroughs comes in. So it's not. The AI is here. It was here for a long time. It's more than like several decades. So maybe around, I can say around 1940s, 1950s. So people started building certain technologies, certain tools, and certain methods to make AI possible the way we have right now. So it evolved over several decades. It's not new. Okay, that's one thing you need to understand. And it is what we have right now is not the stopping place as well. It will evolve further. It has a long way to go, but it will evolve and it will do a lot of good things, and could be some bad things as well, unless human is going to do it better a job in controlling of it or making it better for the human use. But it should evolve, and it will. Okay, so with that, so let's try to recap some of the technology breakthroughs you heard in like last few months, last few years. So we have seen IBM Watson and some self-driving cars. Different companies invented self-driving cars, and then they made it possible. That's not a science fiction anymore. And recently, the more interest coming to the AI field is through the ChatGPT and the DAL-E models. The OpenAI built the ChatGPT, DAL-E, made it available to general public. So it became like a hype, and people started looking into it and started using them, talking about it. A lot of things happen. And there are other developments around it. So the Bing, the Microsoft Bing started using ChatGPT, and they are now Bing search engine powered by ChatGPT became like a very powerful tool. So we can do like we can discuss about the how we can use the Bing to do certain things with a different video, but I'm not going to discuss that here. But that is a very useful tool. It became very useful tool with the ChatGPT and other language model capabilities. And Google released Google Bard AI, which is another conversational AI bot. You can do like many things about with this ChatGPT, Google Bard. You can ask questions. You can do like many things. So you can use it as a personal assistant, and you can use it as an educational guide. There are some the pluses and minuses to that statement. But let's see, like let's try to understand a little bit about the technology, and then you will decide. You should be able to decide whether it's good or bad. Everything has good or bad, right? So you have to decide how I can use it for the good, how I can get the good out of it, and how can I leave the bad out of it. So that's how we should be learning this technology, and that is how we should be using this technology. Okay, so now let's move forward with that. Here I'm going to show you this diagram, because it is something I have to tell a few things about it. This was circulated in last few months with the development of this AI hype. The fastest thing on earth. So that was the title of this social media post. I have seen in many different places, shared by many different people, and many organizations also shared it. But I wanted to give the credit to the original author of three of these image about the cheetah, airplane, and speed of light. So that is coming from original comic strip, which called like Safely Endangered, which is authored by Chris McCoy. Okay, so that was published in webcomics series. Okay, then the internet community took this comic strip and made it to tell a very important story about the AI hype. So what is the message here? We know cheetah is an animal run very fast. So we know that. Airplane travels very fast through air. So we know it's a very fast machine, right? And then speed of light, I don't really fully agree with the scale mentioned here in this comic. It is coming from the original comic strip, but I don't agree the scale, because we know the speed of light is, if you take the scale of cheetah and airplane, it's out of the scale, right? So it's very fast. Okay, so those are like three very fast things according to our knowledge. And then the fourth one is made by the internet community, which is people becoming experts in AI. What is that? People becoming expert in AI with the hype created within last few months with the ChatGPT, DALI, and many other technology came in, and people were talking about it, and then like a lot of things people started talking about it. Everybody talk about it. So that is the humor coming here, right? So yeah, people need to talk about it. There are good things and bad things here. So yes, people should be educated how to use AI, how to use the technology better. People should talk about it. That is how human can evolve. That is how human can share their knowledge. That is how we can make a better use of this technology than being fear of it or being extra hopeful of it, right? So we should be using it for the real use cases to make our civilization better, to make our lives better. But let's take the humor and let's think about like some realistic concept around it. Okay, so here like I really don't agree with the scale of the speed of light, but so that's a comic strip, so let's live with it. So we will try to explain a little bit more with this slide. This is also I saw in a in social media post or several posts actually, but I could not trace back to the original post or to the author. But I am using the concept and I'm using the idea and recreate with some of adding some my own ideas into it. Okay, so this is the message coming out of it. Think of this white rectangle. The boundary in this slide is the community. You can think of the general public. Okay, one quick disclaimer: the scale of the image is not representing the real general public or the proportions of each group I'm going to describe. That's one of the disclaimer. Please understand that, and then we can move forward. Okay, so this white box is the boundary represent the people within, also whoever within the white boundary is the general public. And then people start talking about AI. We discussed about that in a minute ago. So people who talk about AI, we can represent using this gray box. Okay, so that's the people talk about AI. And now people start talking about AI and also they are using it. Not all people talking about AI are the people who are using it. There are people who just talk but nothing they do. There are people who are using the technology or they're using the AI technology as well as having the basic AI literacy. They learn something about it. Okay, so all the people who are using AI are not having enough knowledge about it. They are just the users or consumers of AI products. But those who with the AI literacy can use it better, and they know what it can do, what it cannot do. That's at least the basic literacy. That is a very important thing I will highlight in a short while. Okay, so now let's move forward with the next group. So in the next group, people who use and who has the literacy, significant level of literacy, AI literacy, as well as, so they are the people who can implement stuff. So who build certain tools and who try to make those tools available to general public. So they could be some people who are actually working in AI in the industry. That's another group. So this group will be the people who are building this tool or doing the research and development, bringing this new technology like ChatGPT, DALI, the Google Bard, and there are many different companies from Facebook, Meta, and Amazon. So there are many different companies around the world, and there are various research institutions, universities, and research groups. So they are using the technology and they are inventing new things to make those the people who are in the yellow rectangle to build their products using the people who are in the red rectangle box. The research and development done by them. The actual proportion of this group red and yellow could be much smaller than I can depict in this diagram, but so that could be a very small proportion, but for the illustrative purpose I made it like bigger to help you understand what the concept. I think this will explain something to you. So but what should be our goal? So we are talking about the AI and data science literacy. That is one of the things I am doing with this educational series to help people to build the AI and data science literacy. So our goal should be to have the groups we are showing in blue and green should be expanded across the general public. So that's what I think we should be doing as the people who are working with the technology and who are educating others on the technology. We should make everyone should have at least the basic AI and data science literacy. That is a very important thing for us to move forward as a human civilization. But we cannot avoid using technology. We have to use it, but we have to be aware of how to use it for the best use case. Okay, with that, let's try to understand a little bit about this artificial intelligence people talking about these days. Right? You may heard about this, but I will give you some very high level understanding of it through this next few slides. In very short terms, what artificial intelligence is trying to do? We invented it. Nobody invented for us. The human invented it to mimic the cognitive function of us, means humans. Okay, so that's the artificial intelligence. We are trying to mimic with machines. We are trying to mimic our cognitive functions. You will get to know more about this in a short while. So what is this machine learning? There's another term circulating with artificial intelligence, which is machine learning. So what machine learning is doing? So machine learning is what it is doing is it is learning from data. So the learning from the historical outcome of the events happen, and also from the features of something. So it's learned on data or the prior knowledge. And then machine learning made AI possible. So without machine learning, we probably don't see AI or the artificial intelligence to make the intelligence. So machine supposed to learn. Okay, so that's what we are doing with the machine learning, and that is how the machine learning is coming into the picture. Another thing people forget these days, this AI development, people talking about AI and AI like every time, so they forget about this machine learning is the one is making AI possible. And those language models, so ChatGPT or any other model, DAL-E, the image models, and those things all are machine learning models. People train them using examples, using data. What you are seeing as a product is actually a machine learning model running behind an application to get you the task done. Okay, so there's another term we should be having a understanding on. So that is data science. How the data science is related to machine learning and artificial intelligence, because data science is about everything about the data, right? So we are doing a lot of scientific work around the data. Without data, machine learning is not possible. Machines need to use data to learn from, and your AI should work with machine learning and with the data. Without data, you cannot get these things done. So data science is a very important part of this picture that makes machine learning and AI possible. In very short sentence, I can say these things about the three terms are very important to understand. All right. Now I think you have some good understanding about what is artificial intelligence, what is machine learning, and what is data science, and also the connection between those three. With that, let's try to understand a little bit about the machine learning, because that is an important thing which we need to know to move forward with the generative AI. So in machine learning, we have three different types. How to teach machines, that's basically the topic here. How we can teach machines with a supervised learning. Basically, think about an example. You are having like a large pile of fruits in front of you. You wanted to have a machine to sort them. That's one of the use case you can apply this machine learning. Another example, you can say you wanted to employ this machine in a shop. So the machine should be identify each fruit when the customer show a fruit, and it should identify what fruit it is. If, for example, the customer show an apple, your machine should identify this as an apple and then bill the customer accordingly. To train such a system, you need to train how to identify this object I'm showing as an apple. If I show an apple as an object, how would you do as a human? So you know, like by your historical learning, you learn from as a kid, you learn like you saw the apple first and somebody told you this is an apple. Otherwise you won't know it is an apple, right? You know it is something, but it is not an apple. Someone has to tell you this is an apple. Maybe it is from a book. You learn alphabet, you have the letter A, you have a picture of apple. That could be your learning. You know this picture. When you see it again, actual object or another picture of it, you know that is an apple. That is an example for supervised learning. You get the features or the image of it, you know, you get the label of it. Okay, so let's move to the second type. The second type is unsupervised learning. It is like you are getting another, like a pile of fruit as a human. Like let's think about as human, and then let's think like how machine can do the same thing. Okay, so as a human, if you have a pile of fruit in front of you, someone asks you to sort them into three different groups. So you may have, like in your fruit pile, you may have apple, orange, and banana. You need to separate them into three groups. How would you do? You just take apples into a separate group, banana into a separate group, and orange into a separate group. But how would you do that? You don't need. Do you need to have a label of it? You really need to know what it is? Probably don't. You can group them based on the similarity of apples. We know it, the apples are red. If you think of only red apples available there, apples are red, and there's a specific shape you can recognize among all the apples in that fruit pile. Orange, so you can say, okay, all orange items we put into the orange, the orange fruit and orange color. So you can, the orange fruit is orange color, right? So based on that color or based on the shape, you can put them into a different group. Banana, we know it's a shape of elongated shape, and also the color could be yellow or greenish yellow. So we can group them based on those features. And you really don't need to have a label to do that. Based on the similarity, you group them. So that is kind of unsupervised learning. You are letting a machine to figure out things its own and try to identify patterns and do certain tasks. So both supervised and unsupervised learning are very helpful machine learning techniques. Okay, so the third type is reinforcement learning. If I simply explain it to you, like think of you for the very first time seeing a candlelight, and like if you touch a candlelight, or you get burned, right? So you get hurt. But at first you probably don't remember this. You try to touch it, you don't know you get hurt by touching it, right? So that's a penalty you get when you touch it for the very first time. You hurt. You don't get burned, but you hurt. So is it a good feeling or bad feeling? As a human, we have to decide whether it's a good or bad, right? It's a bad feeling. What we should be doing next time when we see a candlelight, we are not going to touch it, because we register that the bad reward we get. Okay, the reinforcement learning is a very similar to that. Based on the reward or the penalty a machine can get through interacting with the environment, it will learn and then apply that learning in the next step. So this is a very, very high level. I'm not going to go into very detailed introduction, but you should know, like, these are the three different types of machine learning models, training methods: supervised, unsupervised, and reinforcement learning. And these generative AI models, so people train in with a different methods. So some could be a combination of supervised and unsupervised. And also reinforcement learning also be part of the training of the models. So we will talk about that in a later video, but just get the idea. These three types are existing, and you will hear this in many different places. Okay, so let's try to learn a little bit more about the machine learning. So think another example. So previously I mentioned about this fruit classification, identifying a fruit from its shape and color. What do you see here? If you think about it, it looks like a car to me. So why I think this is a car? It is not very clear. It's a very highly pixelated image. Okay, so it's a very blurred image, the pixelated image. It's no clear view of it, right? So how I think this is a car? I say it's a car. For sure it's a car, but I don't know actual picture. So there are some features we knew, or it registered in our mind by seeing different examples of car. But For the very first time as a kid, when you see a car, do you recognize as a car? No, you don't know what it is unless your parent or someone tell you, okay, so this is a picture of a car or this is actual car, and they label you, they give a label to you saying, oh, this is a car. That is how you say this is a car. Otherwise, if someone told you this is not a car, this is an apple, so in future you probably will register that the label of that item is an apple, and you will say, for some people, other people, this is a car, but for you it's an apple. So people can train other people to understand things differently by giving wrong lessons or wrong learning. Okay, so this is a car. So what are the things we can take this as features? So we see like some features like the tires, right, or wheels of the car, and we see some windows of a car, and shape like very similar to a car shape we are very familiar with. Okay, so then how would you recognize it? As a human, we take these features in and we recognize this as a car. And as a machine, how would you recognize it? That's why the machine learning is for the machine also should be able to recognize this as a car. Otherwise, we cannot mimic that human intelligence, right? So as a human, if we could understand this is a car, machine should also be. So that is why we are doing the machine learning, to train machines to understand these things. The machine learning is not only about images. Machine learning is not only about text. So there are various applications of machine learning. You can read more about it, and I will also deliver some content based on various applications of machine learning. In this content, I will be very specific about generative AI, but everybody should have at least the basic understanding of how machine is making these predictions or how this doing that. This is an example for image classification in the machine learning applications. Okay, so now let's look at what is actually machine learning. So let's try to understand the Arthur Samuel, who is a pioneer of AI and machine learning. So he's a great computer scientist. In 1959, I told you like the AI is not something new. They had it for a long time. So he described what is machine learning. It's a field of study that gives computers the ability to learn without being explicitly programmed. Okay, I rephrase, the learn without being explicitly programmed. So what does that mean? In the computer programming, we always give logic to computer. So we have these conditionals, loops, and we write program codes to instruct computers what to do. With the machine learning, we are not doing that. What we are doing is, yes, we are using computer code in the machine learning, but what machines are doing actually is learning from data and trying to find out the path, or what is the path of instructions they need to follow to make some decisions, make some predictions actually. Okay, so that's the learn without being explicitly programmed. It's a very important term, and it's a very powerful term in this definition. Okay, so let's look at another definition, a more recent one. So Tom Michel is another computer scientist, and he explained what is machine learning this way. A computer program is said to learn from experience with respect to some class of tasks, and the performance is measured by P if its performance at the task T as measured by P improves with experience E. So this could be a little overwhelming definition to most of you, but let's try to understand it very simply. Think about you're playing chess. So what is your experience? You're moving one piece. Okay, so what will happen? What is the next experience you get? It could be you're leading towards like winning the game or losing the game. So you will be doing it again and again, so you will get the experience. You can think of that reinforcement example. So you are getting your experience, and that experience should be measured. Okay, taking this move help you to win or lose, or will it be an advantage or disadvantage? So something like that, you have to have a performance measure at each task you do, and based on that you can learn from it and you can adjust your path of like, or the way of your thinking, or the way of your making the decision. Okay, so that's why the experience E, what are the tasks you do, and what is the performance measure, they are the important pieces of machine learning. I'm not going to go into very details, but I will be describing that in a very detail in a later time. Okay, so now let's look at what actually made possible as humans to have our cognitive capabilities. So we all know we have a brain, so everybody has it. So right now you are listening to me and you are hearing my voice, and you are seeing the video or the slides. Everything happened because your brain is processing information coming into your eyes as images, coming into your ears as sound. The signals are processed within your brain, and also keeping you understand about what you are hearing and seeing. What made it possible? So it made possible with the neurons. I'm not a neuroscientist, or I'm not an expert in the neurobiology, but I read from articles, and the many different articles describe about how many neurons in our human brain. We have about 86 billion. Think of the number, like 86 billion neurons in our brain. It's a big number. So why I'm showing you this? We learn about the human's history or civilization, how it evolved from inventing fire, inventing wheels, and we evolved in a with very different inventions throughout the period of time. So many inventions made us improve things, but this is one of the things where we start thinking about our own brain. So we saw something like birds, right? So we saw birds flying, and then thought about why we can't fly. So we invented airplanes. So there are several things we invented by looking at things in nature. So here is a very great invention, because we looked at our own brain and we try to learn from it. So still scientists are working really hard to understand how human brain work. Okay, but we invented something very great for our technological improvement. This is a neuron. A neuron has three main parts. So one, you can say inputs, and then you have the main part, the middle part, that's an information carrier, you can say, and then the other part is the output. What is it common to our computing technology? So if you think about a computer, we take inputs, we process, and we give outputs. We have like ways to transfer the electrical signals within a computer. That's the middle part. You can think of a neuron. So a neuron work as a small computer, you can say. So take input, process within its own nucleus, and then sending the process signal to the output part of the neuron, and then it is connected to many other neurons. So that made a neural network. Okay, so this is like a more clear diagram of it. If you think of a computer, you take inputs here and then process, and then you're sending the signal to outputs, and these outputs are connected to multiple neurons. So that made a neural network. Okay, so what is the relation between this neuron and the artificial neuron we are talking about, or the neural network we are talking about? So computer scientists invented this artificial neuron to mimic the biological neuron. We can make something it's a computational entity, so which can accept inputs like you see in the right side, and then do some processing. And then I'm not going to talk about this activation and some details about the artificial neuron, but we can talk about that later, and do some processing, applying some mathematical formulation. And this like you can think of like the modeling as a mathematical model, so your neuron, and then we are producing the output. So we can create a computational entity with this artificial neuron. So this artificial neurons created the very first way of like neural network systems on the neuron systems in a computer, which called perceptron. When we talk about artificial intelligence, we can say artificial intelligence is a superset of machine learning. Machine learning can have like two different parts. We can say traditional or classical machine learning, and deep learning based on deep neural networks. That is what we are interested talking about today. So what is the relation between data science? Again, like we talked about it before, but data science is something intersecting with those artificial intelligence, machine learning, and other the different types of machine learning. So data science help a lot, or they intersect with these areas, right? People who practice artificial intelligence, machine learning are also knowledgeable in data science. People who data science not necessary to be practiced in artificial intelligence and machine learning, but they are having some knowledge of that. But these fields are intersecting fields. That's what I wanted to say here. But where is generative AI is going to fit into this picture? Because this picture you may have seen in many other locations from many other articles or talks. But let's try to understand how the generative AI is going to fit into this picture. That is not a surprise, because we're talking about this generative AI and the related technology, and we are talking about these neural networks, deep learning, and those things. So we can say generative AI is a subset of deep learning, really. So this is the something we will be discussing. If we take the definition, what is generative AI? It is a type of AI capable of generating text, images, or other media in response to prompts human give, right? You can type a prompt. You interacted with ChatGPT, most likely you did, or you interacted with DALI, or maybe a similar other image generation tool, or many other tools available you interacted with. So you give a prompt. You say, I want a picture of something. I will show you some example in the next video. Don't worry about it. I will show you some examples. But here, if you give something like a prompt, and your tool will provide you a response. Okay, so that's a generative AI. It will generate content based on what you provide it in. Okay, we will talk a little bit more about it to understand generative AI better. Okay, so there's another term circulating these days, generative AI. So we have now a lot of generative AI applications. But what is the term called artificial general intelligence? If it abbreviated generative AI and artificial general intelligence, this is where it looks similar, like but one letter we can move around, and you can say whether it's the same. But in the discussions also, the same thing I mentioned earlier, people talking about these things without knowing exactly what they are, and will speculate a lot of things, and people think, okay, so it's artificial general intelligence, I'll describe it in a minute, is same as generative AI, or maybe generative AI is doing artificial intelligence. So we should be more careful about these claims. We should be thinking more, and should be learning more before we are making such claims. So what is this artificial general intelligence actually is? Artificial general intelligence is a hypothetical type of artificial intelligence that would be able to understand or learn any intellectual task that a human or animal being can. I forgot to highlight things, but highlight these things in your own. Any human intellectual task. Okay, so you can do certain things. Can a machine can do same thing as you? Can ChatGPT do everything as you? Yes, it can provide you answers given your prompt. It can generate content. DALI can generate an image or like a photograph by combining a lot of things. But it cannot do everything a human can do yet. Okay, if you want to do or implement such an artificial general intelligence system, not only the ChatGPT like tool, or DALI like image tool, you have to combine a lot of things together. If I go back to the previous slide, I forgot to mention your human body. As a human, we are working with many different sensors. The one sensor is your eye. That's a vision sensor. You see things. Ears, you hear things. Your mouth, it has some sensors as well as your output device. You can speak. I speak using my mouth. Your hands can be sensors or output device, or maybe it helps you to move things around, or to give some sign to another person, or to do certain things. Your hands will help you to draw things. To have a computer with a artificial general intelligence, a computer should be able to do things you're doing with your own human body using your brain capabilities and your cognitive capabilities. You should be able to the machine should be able to do this. So the machine is not simply what you are seeing as ChatGPT, but it should be a very complex or very advanced system to achieve this artificial general intelligence. That is what I have to say here. So therefore, you cannot assume what you are seeing with these generative AI tools we are seeing these days in our general public use are not artificial general intelligence. You cannot expect at this point. Probably it will go to that level, but not at this stage. Alright, so this is the end of this video. So in the next video, I'll be showing you some examples of generative AI, and it would be fun to see what are the different examples, what are the things we can do with generative AI, and then we will move forward with the applications of real world problem solving, how we can apply generative AI for real world problem solving, and then I will move towards actually solving some problems using open source machine learning models and also the libraries available. We can do we can apply generative AI using tools like ChatGPT or Azure OpenAI or Google, many other the platforms offer you services you can use right away, and for like a subscription or payment. And also you can build your own tools using many open source models people developed and released for open general public use. So we'll try to explore some of the available tools and libraries to build our own generative AI applications to solve some real problems. So I will discuss more about it in the next video. See you then.